Welcome to part 3 of Office Automation. For those who have watched part 1 and part 2, thanks for hanging in there. Part 3 I think is very exciting because we're bringing all of these concepts together and building a modeling engine that will be able to forward emails to the correct department. In the case of the model, we'll be able to classify which department a new email belongs to automatically. As usual, all the code, everything is on the website. You can follow the link on the screen. Quick recap, part 1, we looked at Word2Vec off of TensorFlow's website, and we modeled the Enron dataset and then clustered the results and kind of realized that the clusters, the themes it pulled were not very clear, were not well formed. We then used pre-trained word vector embeddings, and there it was, night and day. Very clear themes. We could really tell, important themes, important stories that were contained within the Enron dataset. And in this video, we're going to use these themes that we found in the Enron dataset, create departments using words found in these themes, and then build a classification model on top of these themes, and decide where a new email belongs to, which one of these departments it belongs to, and you should have imagined that this is there's an automated engine that will then forward those new emails automatically with no human intervention. Let's look at some code. The beginning of the code, I'm gonna glance over the beginning of the code because this is the kind of code we saw in part 1 and part 2. We pulled the Enron data set, we cleaned it up. We ended up with a data set made up of date, subject, and content. Everything else we threw out. We also put everything to lowercase, used only alphabetic characters, nothing else, and removed any spaces. We then build our dictionaries and a reverse dictionary. This is basically a list of all the unique words seen in the dataset that have been used, the words used the most, the 50,000 words used the most, and how many times the frequency was seen. All the other words are tagged as unknown, right? So we know we only have 50,000 unique words plus, unknown. And finally, we use the glove dataset, right, to create our clusters. So we're taking these 50,000 words, we intersect them with the glove dataset, which has over 2 million words, and we pull the 50,000 words, or at least whatever we can find matching between both datasets, and get rid of everything else. And now we have, almost let's say 50,000 words and 300 word vector embedded dimensions per each word. So basically, each word will now have a context that's described through 300 numbers. That's what we were looking at, in video 1 and 2. From those words, right? We're going to create from those vector dimensions. We're going to create 500 clusters. I'm going to use k-means to create those clusters, and then we're going to look at these clusters and pull out 6 very strong themes to create our hypothetical department. That's what we need, right? Because we're looking for an outcome variable, in this case multi-class outcome variable, which to train a model. So I actually ended up using multiple clusters that I found. I'm not going to run it here because it takes, these 500 clusters takes between 30 minutes and an hour when you run it. So give it some time. On my MacBook it took a fair amount of time. And then I went through these 500 clusters manually and pulled what I thought were strong themes for our classification model. First one is legal. I think this was 2 clusters. Communication, and you'll see there's counsel, judges. You'll see there's all these legal words. Same thing for communication. This was multiple clusters also. Security department, a support department, energy department, and a sales department, right? So I have about 100 to 200 words per department, per these hypothetical departments. Keep in mind that if you have if you want to apply this to your own business you don't have to use the Enron dataset, right? You'd be using, preferably be using your own words you find in those departments. For example, you could collect a sample of emails for each one of your departments and then pull those out and use those as your keywords. It doesn't matter if you only have 20 or 100 words, right? Even though I have 100 to 200 words, that's plenty to get us started. Keep in mind, a new incoming email probably may not have, any words in my sales department bag of words. It may be using different words. So we need to do one more step to make sure we have enough words to capture new incoming emails that we've never seen, we've never seen before, so we couldn't train on it. And how we're going to do that is using a cosine distance. Cosine distance basically is it's a powerful algorithm that can then look at multiple numbers in a row. Imagine a big matrix and figure out from let's say a series of 100 numbers, or even better, a series of 300 numbers in each row, right? This is what we're dealing with, right? Each word has a vector representation made up of 300 words, 300 numbers, and cosine distance will then find out of every one of these rows which is the closest one to a particular row, and that's what we're going to do. So one thing I have to mention here is we're going to do the same thing we did before when we created these clusters, right? We're going to call glove dataset, but we're not going to intersect. We're not going to say every word that's in Enron, give me the word in glove, and everything else throw out. Instead here we're going to say give me everything, right? Almost everything. I'm saying no. Give me only words that are lowercase, and give me only words that are made of alphabetic characters. Anything with numbers or special characters, I'm throwing out. And you may not want to do that in your production setting. You may just want to use everything. So what we end up having is, instead of being kept to 50,000 words as we were before, I already went here, we end up with 400,000 words out of 2 million words. So these 400,000 words, a lot of these are not contained in the original Enron dataset, and it's going to allow us to boost our bag of words. Instead of just having 200 words, we're now going to have 1,000 words per department, and hopefully be able to capture new incoming emails we've never seen or with no intersecting words. And this is the code here, right? This is the code where we do the cosine distance, and that's what's interesting. So once you end up having your in our case 400,000 words with their vector dimensions, we then run through each one of our department words, right? For example, pick one, right? A voucher. We're going to take the word voucher, and we're going to run through this code for the word voucher. I'm going to say, for the word voucher, give me 5 closest words you find in the glove dataset, and it's going to use the cosine distance function, right, to say it's going to pull the 300 dimensions that represent the word voucher, so just one row, and find out all the rows in the glove dataset that are closest to our one word voucher. And it's going to return. And the way we do this is we take a copy of our dataset, right, of our glove dataset, which has about 400 plus thousand words. We make a copy of it, and then we say we pass this copy to our cosine distance formula, and say add a new column, a numerical column, to this dataset. And that column is going to be made of the distance, how far all the words are to our keyword. In our case, in this case, voucher, right? So it's going to add a new column at the end of the data frame, right? We have a word, 300 dimensions, and now we're going to have an extra column at the end, which is going to be the distance from every single one of our 400,000 rows of how close they are to the word voucher. And then we're simply going to sort it, right, in reverse order, and get the top 5. And that's how you pull 5 words that are very similar, the closest to our keyword voucher, right? So it's a bit complicated, but I would recommend you take time to understand this concept, because a cosine distance is an extremely powerful concept. There are other ways you could find similar words, right? You could actually use clustering, for example. Say, hey, find me the closest words to this particular word. I think Jensen uses k-means clustering to find the closest words. But here we're using cosine distance because it's pretty powerful as well and pretty fast. So for each one of our words in our departments, we're now going to boost each one of those by an extra 5 words. Okay, it's not going to be, a 1-to-1 or a 1-to-5 because some of them are going to be duplicated. But we're going to go from, let's say, 1,000 words for our 6 clusters, for our 6 departments, and we're going to probably boost it to 10,000 words or something like that, right? Pretty powerful, pretty cool, and hopefully be able to handle any future incoming email. That's what we really want. Let me see if I have this, if I can show this. Hold on. This could be interesting. It's an array. And let's do this. Yeah, so here is an example, right, of the distance, right? This whole form, for one word, right, for one word, actually I can tell you what word it is. That was the last word when I ran it. For a word that doesn't mean anything, Zulu, whatever, it found the distance to all the other words, right? For this word, if and then we basically append that's the column, the distance column we append to the matrix, we sort it, and then pull the top 6 for this word. So, and definitely look into the final clauses. There are some funny words. Some things don't make sense, and you may want to go in and kind of understand why some of these don't make any sense. I don't think it's going to hurt the model. You'll see the model performs very well in the end, so it's not a big deal, but there are definitely some silly words in there. That's the cost of trying to do everything in an automated fashion. Okay, so next, what we have to do next, right, is we now have our departments, 6 departments, now boosted with each maybe let's say 1,000 words, so a lot of words. So now we need to go back to our Enron email dataset, and we need to create we need to engineer our features. So for each email in the Enron dataset, we want to add 6 columns. And so this should be pretty obvious, right? Each email now is going to have a group of legal word counts. So how many words in our legal department you found in that email. Same thing for communication. Same thing for support, energy desk, etc. We're also going to get some general features from the emails. We're going to count the length of characters in the subject line, the length of words in the subject line, the length of words in the content, the count of words in the content, if the email was sent in the morning or in the afternoon, and if the email was sent during the week or weekend, right? So these are just basic, I'm just kind of showing you some examples of extra features you can pull from your emails. Keep in mind that these didn't prove very predictive in the end for the Enron dataset, so I actually did not include a lot of these, but they may prove a lot more predictive depending on what your business is. If you do a type of business during the week and weekend, then you definitely want to pull, is it the weekday? And if your behavior in the morning is different than the afternoon, you want to. If you have very different behavior between every hour of your business day, you may want to pull features, create a feature engineer, everything that happened between 8 and 9, everything that happened between 9 and 10 a.m., etc., etc., right? So think about what is important to your business and try to represent that into features. And that's what you do here, right? We're simply looping through each email, right? This takes a little while. Loop through each email in the Enron dataset and count how many words you find that pertain to the legal departments, security, etc., etc. And in the end, you end up with this training set. Let me just give you a look at this. And it's simply how many, the content lengths, word count. Okay, that's a bug here. That should not be the same. Oh, I'm seeing that so the code I'm seeing the subject length and the word count are the same, and they shouldn't be. It looks like this is the word count and not the number of characters. So I'll definitely revisit that on the code I publish. But more importantly, you see that it's found in this email, the one I'm showing currently, it's found 4 words in the support department. Nothing in the legal department, nothing in the sales department, nothing in the security department, communication, etc. So we know more or less that this will be forwarded to the support department, right? So we end up basically translating each email into a series of features, which are these. Right, we end up translating into these. Let me just get a count here, into these 14 features. And that's what we're going to use. These are the quantitative features that we're going to use and to train our model, right? Because you can't train your model directly on words. You need to find a way of representing it into numbers, and from there we now can train a model, and that's what's pretty cool. Okay. So I'm actually going to run all this. Actually, I don't need to run it because I save it onto text. I save it to CSV a bunch of times, so you can just pull it from there. So that's what I'm going to do, because I just want to show you the modeling part. Okay, so I put it on pause just to read it, the CSV, and now we can look at it, right? So here we have it, right? This is, we have, how many do we have? We have 317,000 rows, so 317 rows. And you may ask, why is it 317 when we started with 411,000? Well, that's a very good thing, and I want to make sure I mention this, is I removed anything that did not have any word that pertained to at least one of our departments. If you had an email that didn't fit into any of our 6 departments, I threw it out, right? And this is something you got to keep in mind, right? Because this could hurt you if you have incoming emails that has no idea where it goes. You may want to instead create a 7th department and call it unknown department, where everything that doesn't fit in these 6 can go to, right? And instead, I'm just saying, anything that's unknown, I'm just removing for simplicity's sake. Something to think about. So here we have a data set, right? It's made up of the content length, word count, how many words were in different departments. As you see here, we have, and you can have, of course, words in, in intersecting departments, right? So this email here had 2 words in communication department and 1 word in the energy department, and that's fine, right? That's going to happen. We also have the raw text and subject lengths and our feature, our engineer. Was it sent in the morning? Yes, no. Is it a weekday? Yes or no. Okay. So let's run the modeling here. So I put this in memory. Okay, we're creating, we're splitting the data into 3 different data sets, 1 for training, 1 for testing, and 1 for validation. We then create our tensors, right, for each one of our values. Most I'm using, considering them real values. A few I'm playing around with buckets, right? You could play around with buckets. It didn't prove predictive in this case, but it's something that you can use depending on the type of model you use. And is it weekday or is it in the morning? And let's get the. So here's the model we're going to use. It's called is from the higher level API TensorFlow Contrib Learn, right? Just think of it as like a scikit-learn, where the model is really good underneath, but you don't have to worry about the minutia. It's already all there. It's a design pattern of models taking care of taking things care. It's taken care of for you, but you still do have some parameters you can tune. For example, it allows you to add how many hidden layers you want and made up of how many neurons. So in this case, we're saying, we want 2 hidden layers of 20 neurons each. We say classes, right? We have 6 departments, so we only have 6 classes. That's important because it's a multi-classification model. And you pass it the features that you want. So I put 2, right? Depending on the model you use. This is for DNN classifier. You could pass it some more complex features that we built. I didn't find them predictive. It actually confused the model the way I was doing it. So I'm still putting them there unless in case you want to experiment with it. Instead, I'm just using the 6 departments, the counts of the 6 departments, nothing else. That proved to be the most predictive. So you pass those to your deep neural network classifier. Keep in mind, here we're just, this is dealing with graphs, right? We're building the pipeline for the model. We're not passing any data yet. We're just telling it what kind of data, the data types, how it's going to run it, and that's all we're doing, right? It hasn't dealt with any data yet. So let me just copy this. And I'm putting some links in the text if you're interested into how TensorFlow works. we have an input function. The input function is exactly where you use these tensors, right? This graph model, right? It basically pipes going to the model with no data, and this is where you actually pull the data and feed it into it, right? It takes the data frame, and here you're saying, what are your continuous columns, what are your categorical columns. It packages all together, and then packages, basically takes your data, packages it into the correct TensorFlow pipelines, and returns it to for your model fitting. And this is where the magic happens when you run your classifier fit. We're saying run this, try it through 200 iterations. And sometimes you may want to give it more time if it's more complex, or if you have more data, less time if you have less data. And let's look at our results when it's done. It takes a bit of time, so give it the time it needs. There we have it. Went step 1, step 101, and we're asked for 200 steps, so a few more steps. And once it's done, we'll look at the results. So when a TensorFlow model, you're basically doing a lot of prep work where you're building the pipelines, and then you pass it the data, right? So the idea is that you end up having this model that's ready to go. It knows exactly the type of data it's going to expect, and from then on it can work a lot faster because you've done a lot of preparatory work for it. So let's see how we're doing here. I'm gonna I'm going to evaluate the model with our by passing it the evaluation, and it's giving us a very good accuracy, very good AUC, and it should, right? Because we created our own outcome variables. It'd be ridiculous if by creating our own outcome variables the model couldn't pick up on that. Okay, so the key will be when we remember we split the data set into three parts: training, testing, and evaluation. So it tested very well. The reality of how well it does is when we pass the evaluation. A data set it has not seen yet, and that's what we're going to do here. We're going to count how many buckets it found to make sure we're good. Yes, it found 6 buckets from 0 to 5. That's good. And we're going to look at a confusion matrix, right? So you see it did really well, right? So the confusion matrix is with our evaluation data. So data the model has not seen. And you can see it does really well, right? The majority of the communications went to communications, energy went to energy. You can see right in the diagonal, right? That's the bulk of the so support did a little bit less well, legal did less well, and that's probably because they have a lot of words that spill from one department to another. If you really want your model to work really well, make sure your departments are very different from each other, right? If this really muddled, maybe they should be a single department and then have a human figure out what's the best email to go, right? If they're too close together, the model's going to get confused. Okay, so one last thing I want to show before I end this is we're going to create a hypothetical email. I just wrote it, right? I'm saying to the help desk, my monitor stopped responding and I need to get the spreadsheet finished as soon as possible. Please help me, okay? And I've created a small function. It's right here. Let me just load it in memory. It basically does exactly what we did for the whole data set, right? It's going to figure out, let's look at it here, it'll be easier. It's going to take each word. It's going to take the subject, then the content, clean it up, right? Do some scrubbing, and then it's going to figure out the feature engineering. Was it sent in the morning, in the afternoon, and how many words it's found that pertain to particular departments that we have. Okay, and it's going to return a data frame. It's only going to have one row, right? Because I only passed it one email, and let's call it here. And if we look at it, we see that my little email, this is what the bug we were seeing earlier. I need to fix that, right? There should be different counts on the content length, character length, and word count. So I'll fix that. But more importantly, for the model, we're only using our group, our departments. It has nothing in communication, nothing in energy desk, nothing in legal, nothing in sales, nothing in spam, and it has 4 words that belong to the support department, right? We know it's going to be we know this is going to be categorized, classified in the right department, right? So let's see. All right, so I'm going to pass it to our prediction, and it says group 3. Let's see what it is. Forward request to the help desk. Okay. So I mean, of course, this is a sentence I created myself. Where are you? You're here, right? I made sure I picked words that didn't spill into any other department, right? I basically, completely cheated on this one because I knew it was going to work. But this gives you kind of the code to then handle new incoming emails. And the challenge here really is going to be dealing with new emails. There's so many different language shifts. People use different types of words. If the model has never seen these words before, it's just not going to be able to classify them unless you have a lot of additional features that that can help it, right? Such as maybe one department only works in the morning and another department only works in the afternoon, right? That's going to help the model. Maybe you have different departments in different geographical locations, and you use an NLP package that figures out if where an email came from and to what location it was sent. If there are specific people's names in there, right? You have to use more than just these bag of words, but this is definitely the bulk. The heavy lifting is done by the bag of words. You may want to add some finesse with extra features. Okay, so I'm going to end it up there. The code is all here. Keep in mind some of that code, if you're going to be using the Enron dataset, can take a while. I think the clusters took me like almost, I want to say maybe like 45 minutes to create those 500 clusters. So just keep that stuff in mind. Some of the stuff is super slow, but very rewarding, right? To go from a huge data set of 500,000 emails and ending up with a classification engine that can tell, what department that email belongs to. Thanks for watching.